Welcome, dear listener. Tonight, we're diving deep, not into today's oceans, but into ancient seas that vanished billions of years ago. Oceans that once covered alien landscapes. Waters that birthed the first life. Tides that shaped continents long before humans walked the earth. These ancient oceans hold secrets, stories written in stone, fossils of creatures that swam when Earth was young, chemical signatures preserved in rocks. Tonight, we'll explore these vanished worlds together, gently, slowly, letting the rhythm of deep time lull you into peaceful rest. If you find comfort in these journeys through time, consider subscribing to Sleepy Science Channel. We're here every night, turning the mysteries of science into pathways to sleep. But for now, settle into your pillow, let your breathing slow, close your eyes if you wish, and let's descend together into Earth's ancient waters. Let's begin. Earth's first ocean appeared 4.4 billion years ago, just 150 million years after the planet formed. That's astonishingly fast. Earth was still being bombarded by asteroids, its surface a hellscape of molten rock. Yet, somehow, water survived, or arrived. Scientists found this evidence in a single mineral, crystals orcon, no bigger than a grain of sand. That tiny crystal preserved oxygen isotopes that only form in the presence of liquid water. One grain of sand, telling us the ocean is almost as old as Earth itself. But where did the water come from? It couldn't have formed on early Earth, too hot. Water would have evaporated instantly, so it came from space, delivered by asteroids and comets, icy bodies from the outer solar system crashing into the young planet. Each impact brought water. Millions of impacts over millions of years. Gradually, the bombardment lessened, the surface cooled, steam condensed, and the first ocean-filled ancient basins we can no longer see. This primordial ocean was nothing like today's. No oxygen in the water, no oxygen in the air. The sky was orange, thick with methane and carbon dioxide. The ocean was acidic, rich in iron. When iron met the small amounts of oxygen produced by early photosynthetic bacteria, it rusted, precipitated out, formed layers on the ocean floor. Those layers became banded iron formations, red and black stripes in ancient rocks found in Australia, South Africa, Minnesota, monuments to an ocean we've never known. The ancient ocean was warmer, much warmer. Surface temperatures might have reached 40 to 50 degrees Celsius, hot enough to hurt your hand, but not hot enough to boil. Life, if it existed, then would have thrived in this heat. Thermophiles, heat-loving microbes, the ancestors of all life on Earth. They didn't just survive the heat, they required it. To them, our modern ocean would be freezing, inhospitable, deadly. 4 billion years ago, Earth had no continents, just endless ocean covering the entire globe. A water world. The only land was scattered volcanic islands, temporary, constantly sinking back into the mantle. There was no stable crust yet. Tectonic plates hadn't formed the way they exist today. The planet's interior was hotter, more convective, the surface more fluid. Earth was still figuring out how to be a planet. The first true continent appeared around 3.5 billion years ago, called Yor, a small landmass, maybe the size of Madagascar. It was the seed. From this tiny fragment, all future continents would grow. Yor still exists today. Its remnants are scattered, fragments found in Australia, India, South Africa, the same rocks, the same age, once joined, now separated by thousands of kilometers. Continental drift tore Europe apart. But geology remembers. The rocks match. The minerals align. The story is written in stone. Ancient oceans had tides just like today, but the moon was closer then, much closer. 3 billion years ago, the moon orbited at half its current distance. Tides were enormous. Water might have risen and fallen 50 meters twice a day. Imagine standing on an ancient shore, watching the sea retreat 5 kilometers, then return twice daily. The tidal zone would have been a unique environment, alternating between flood and drought, heat and exposure. Life had to adapt, and it did. The first life appeared in the ocean, not on land, not in hot springs, in the water, around 3.8 billion years ago, maybe earlier. We don't know exactly when or where. The earliest fossils are ambiguous. Tiny structures in rocks, could be bacteria, could be minerals. Scientists still debate, but chemistry suggests life arose early, as soon as conditions allowed. Life is not fragile. It's opportunistic, aggressive. Given liquid water and energy, it emerges. These first organisms were simpler than any cell today. No nucleus, no organelles. Just a membrane enclosing self-replicating molecules, but they could reproduce, pass information to descendants, mutate, evolve. That's all evolution needs: reproduction, variation, selection. With those 3 ingredients, complexity builds over billions of years, from simple cells to complex ecosystems, from chemistry to consciousness. For 2 billion years, life remained microscopic, single-celled organisms only, bacteria, archaea. The ocean teemed with them, but you couldn't see them without a microscope. From space, Earth would have looked lifeless. Blue oceans, brown islands, no green, no forests, no animals. But the ocean was alive, invisibly alive. Trillions of microbes. Around 2.4 billion years ago, everything changed. Cyanobacteria, photosynthetic bacteria, had evolved. They could split water molecules using sunlight, releasing oxygen as waste. At first, oxygen didn't accumulate. It reacted with iron and sulfur in the ocean and rocks, got absorbed, neutralized. But eventually, all the iron and sulfur was oxidized. Oxygen began accumulating in the atmosphere. This event is called the Great Oxidation Event, the most significant transformation in Earth's history. The Great Oxidation Event was a catastrophe for most life at the time. Oxygen is toxic, it's reactive, breaks apart organic molecules, damages cells. Most organisms in the ancient ocean couldn't tolerate it. They died, went extinct, retreated to oxygen-free refuge, deep sediments, hydrothermal vents, the guts of other organisms. Some still live there today. Anaerobic bacteria, hating oxygen, surviving in the few places it doesn't reach. But some organisms adapted. They evolved ways to use oxygen. Aerobic respiration, breathing. Oxygen releases far more energy than anaerobic metabolism, about 18 times more. This energy windfall allowed complexity. Cells could afford to be larger, more intricate. Eukaryote cells with nuclei appeared around 2 billion years ago. They were the ancestors of all plants, animals, and fungi. Without oxygen, we wouldn't exist. The poison became the fuel. The catastrophe became the opportunity. The ancient ocean turned red, literally, as oxygen accumulated, dissolved, iron oxidized, rust. For hundreds of millions of years, iron oxide rained down onto the ocean floor, layer upon layer, forming banded iron formations. These formations are now mined for iron ore. The steel in your car, the nails in your walls, the beams in skyscrapers, all came from ancient oceans, from oxygen produced by bacteria billions of years ago. You drive on prehistory, live in fossils, use ancient air. Around 1.8 billion years ago, a new ocean formed, not globally, but regionally. The Columbia supercontinent had assembled. Most of Earth's landmasses joined together. Between them lay the Columbia Ocean, vast, warm, isolated. This ocean lasted 400 million years. Then the supercontinent broke apart. The ocean closed. New oceans formed. The cycle of supercontinent assembly and breakup has repeated many times. Columbia was just one iteration, one turn of the wheel. Earth's oceans have opened and closed like breathing. The Wilson cycle, geologists call it. Continents drift apart. A new ocean opens, widens. The Atlantic is doing this now, growing a few centimeters per year. Eventually, the spreading stops. Subduction begins. One ocean plate dives beneath a continent. The ocean shrinks. Finally, continents collide. Mountains rise. The ocean disappears. Then the cycle begins again. New rifts, new spreading, new oceans. Earth's surface is in constant motion, slow but relentless. The oldest ocean floor we can find today is only 200 million years old in the eastern Mediterranean. Why no older? Because ocean crust recycles. It forms at mid-ocean ridges, spreads, eventually reaches a subduction zone, dives into the mantle, melts, gets recycled. Every 200 million years or so, the entire ocean floor is replaced. Ancient ocean floor is gone, subducted, destroyed. We know ancient oceans existed only through indirect evidence, sediments deposited on their floors, fossils of creatures that lived in them, chemical traces in continental rocks. But the water itself is ancient. The same water molecules. Water doesn't get destroyed. It cycles. Ocean to atmosphere, to land to ocean. The water in your glass might have been in the Panthalassic Ocean 300 million years ago, when trilobites crawled the seafloor, or in the Tethys Ocean when dinosaurs ruled. Water is immortal, recycled endlessly. You're drinking history. Around 750 million years ago, Earth nearly froze, solid. Snowball Earth, ice, covered the oceans, from pole to equator. Ice, kilometers thick. Sunlight reflected back into space. The planet cooled further. Positive feedback. Runaway glaciation. How did life survive? In refuges, hydrothermal vents, volcanic islands, punching through the ice, cracks in the ice, allowing sunlight. Life clung to the edges, barely, but enough. The ice lasted for millions of years, 10 million, maybe more. Then volcanic activity saved the planet. Volcanoes continued erupting, releasing carbon dioxide. CO2 doesn't dissolve in ice like it does in water. It accumulated in the atmosphere. Greenhouse effect intensified. Temperatures rose. Ice began melting. Once it started, it accelerated. More open water, more sunlight absorbed, more warming. Within a few thousand years, the ice was gone. The oceans returned. Life exploded back into the newly thawed world. The Ediacaran period 635 to 541 million years ago saw strange creatures, soft-bodied organisms, unlike anything alive today. Dickinsonia, flat, quilted oval, could grow a meter long. No mouth, no gut. How did it eat? We don't know. maybe absorbed nutrients through its skin, maybe photosynthesized. It doesn't fit into any modern category. Not animal, not plant, not fungus, something else. An experiment in multicellular life. One that didn't continue. Ediacaran organisms went extinct, left no descendants. Evolution tried, failed, moved on, but these creatures left trace fossils, impressions in ancient seafloors, preserved in sandstone, found in Australia, Namibia, Newfoundland, Russia, all over the world, proving these organisms were widespread, successful, dominant. Then they vanished, about 541 million years ago, right before the Cambrian explosion. Did the new Cambrian animals outcompete them, eat them? We don't fully know, but the Ediacaran world ended, and a new world began. The Cambrian explosion 541 million years ago changed everything. Suddenly, in geological terms, the ocean filled with complex animals, trilobites, armored arthropods with compound eyes, Anomalocaris, a predator, a meter long, grasping appendages, circular mouth, Opabenia, 5 eyes, a proboscis, like a vacuum hose, Hallucigenia, spikes on its back, legs underneath, walking on stilts. These creatures looked alien, and they were, from a world so different from ours that our categories barely apply. But they had hard parts, shells, exoskeletons, mineralized structures. For the first time, organisms could fossilize well. Before this, soft bodies, rarely preserved. The Cambrian gave us the fossil record. Suddenly, the history of life became readable, written in stone. We owe much of what we know about ancient life to the Cambrian innovation of hard parts. Why did complexity explode then? Scientists debate. Maybe oxygen levels finally reached a threshold, enough to support active, mobile animals. Maybe predation drove an evolutionary arms race. Prey developed shells, predators developed weapons. Maybe eyes evolved, vision changed the game. Predators could hunt from a distance. Prey could see danger approaching. The Cambrian was the dawn of modern ecology. Predator, prey, competition, cooperation, all in the ancient ocean. The Burgess Shale in Canada preserves this world beautifully. 508 million years old, soft tissues preserved, guts, gills, eyes, muscles. We can see what these animals looked like in life, reconstructed, imagined. Paleontologists spend careers studying these rocks, finding new species, reinterpreting old ones. Each discovery rewrites our understanding. The ocean's history is still being written, still being discovered. Trilobites dominated the ocean floor for 270 million years, far longer than dinosaurs ruled the land. Over 20,000 species, tiny ones a millimeter long, giants over half a meter. They had compound eyes like insects, hundreds of lenses, each one a crystal of calcite, perfectly transparent. Some trilobites could see in near darkness, others had eyes on stalks. Periscope vision. Evolution explored every possibility, every niche, every variation. Trilobites could roll up into balls, like pill bugs, for defense. Their exoskeletons were jointed, flexible, allowing them to curl. Fossilized trilobites often show this posture. Died in defense, preserved in fear. A behavior from 500 million years ago, still visible, still understandable. Life's strategies haven't changed much. Roll up, hide, hope the predator loses interest. Trilobites molted as they grew, shed their exoskeletons. Each molt left behind a fossil. So a single trilobite could leave dozens of fossils throughout its life. Most trilobite fossils are shed exoskeletons, not bodies, ghost armor, empty shells, echoes of growth. The trilobites grew throughout their lives, slow, steady, adding segments. Each molt a step toward adulthood. The ancient ocean had reefs, not coral reefs. Corals hadn't evolved yet, but stromatolite-slayered structures built by cyanobacteria, photosynthetic mats, building limestone, layer upon layer, year by year. Stromatolites formed reefs, kilometers long, providing habitat for countless organisms. They're still around today in a few isolated places: Shark Bay, Australia, the Bahamas. Living fossils, survivors from a time before animals. Stromatolites are Earth's oldest fossils. Some date to 3.5 billion years ago. For 2 billion years, they were the dominant life form, the architects of the ocean, the primary producers. Then animals evolved, grazing snails, burrowing worms. They ate the bacteria, disrupted the mats. Stromatolites couldn't compete. They retreated to extreme environments, hypersaline lagoons, places too harsh for grazers. That's where they survive today, refugees in their own world. The Ordovician period, 485 to 443 million years ago, saw the rise of fish. Well, protofish, jawless, armored, bottom feeders. They looked more like armored tadpoles than modern fish. No paired fins, no jaws, just a sucker mouth for feeding on detritus. But they had a backbone, cartilaginous, flexible, the beginning of vertebrate evolution. From these awkward swimmers came all vertebrates: fish, amphibians, reptiles, birds, mammals. The Ordovician Ocean had massive arthropods, sea scorpions, eurypterids. Some grew to 2.5 meters long, larger than a human, claws, segmented tail, compound eyes, the largest arthropods ever to exist, apex predators of their time. They swam through ancient seas, hunting trilobites, fish, each other. Imagine diving into the Ordovician Ocean, seeing a sea scorpion glide past, pincers wide, eyes tracking you. Nightmare fuel, or wonder, depending on your perspective. But eurypterids weren't immortal. They went extinct 252 million years ago, the Permian extinction. The worst mass extinction in Earth's history. 96% of marine species died. The ocean nearly emptied. Reefs collapsed. Food webs disintegrated. It took 10 million years for diversity to recover, the longest recovery in the fossil record. What caused it? Volcanic eruptions in Siberia, massive, releasing carbon dioxide, sulfur dioxide, methane. Climate destabilized, oceans acidified, oxygen levels plummeted. Life couldn't cope. It died. But 5% survived, the toughest, the luckiest, the most adaptable. From that 5%, all modern marine life descends. Every fish, every whale, every crab, every coral. You can trace their ancestry back to the survivors, the ones who endured the worst. Life is resilient beyond comprehension. Even when 96% dies, the remaining 4% rebuilds, diversifies, fills the empty niches. Evolution starts again. After the Permian extinction, the ocean was strange. Low diversity, few species, but the survivors thrived. No competition. Empty niches. Fish radiated rapidly. Sharks, rays, bony fish. They filled every role: predator, prey, filter feeder, scavenger. Within 20 million years, the ocean was full again. Different species, different ecosystems, but full. Nature abhors a vacuum. Life rushes in, always. The Mesozoic Ocean, the age of dinosaurs, had marine reptiles. Not dinosaurs, reptiles that returned to the sea. Ichthyosaurs, fish lizards, streamlined, dolphin-shaped, fast swimmers. Plesiosaurs, long necks, four flippers, graceful, maneuverable. Mosasaurs, giant lizards, predators, apex hunters. Some grew to 17 meters long. These were not fish. They were reptiles, air breathers, lungs. They had to surface, had to breathe, yet they thrived in the ocean for over 100 million years. Ichthyosaurs gave birth to live young. We know because fossils show babies inside mothers. They couldn't come ashore to lay eggs like turtles, too specialized, too aquatic, so they evolved live birth in the water. The babies emerging tail first to avoid drowning. Evolution solves problems, sometimes elegantly, sometimes crudely, but it solves them. Ammonites filled the Mesozoic Ocean, relatives of modern squid and octopuses, but with external shells, coiled, chambered, beautiful. They ranged from coin-sized to over 2 meters in diameter. Thousands of species, every shape, every ornament. Smooth shells, spiked shells, collectors treasure ammonite fossils, polish them, display them, hold one online, hold 100 million years in your hand. The ocean made art long before humans did. Ammonites used their shells for buoyancy. Like submarines, each chamber filled with gas or liquid, adjusting the ratio controlled depth, sink to hunt, rise to escape, simple, effective. The Nautilus, a living relative, still uses this system today, swimming through tropical waters, a living link to the Mesozoic. Hold a Nautilus shell to your ear. You're not hearing the ocean. You're hearing blood flow in your ear. But it's a romantic thought. The ocean speaking through its ancient child. The Cretaceous ocean was warm, much warmer than today. No ice at the poles. Tropical temperatures extended to 60 degrees latitude north and south. Palm trees grew in Alaska. Crocodiles swam in the Arctic Ocean. Sea levels were 170 meters higher than now. Much of the continents were flooded. Shallow seas covered the interior of North America, Europe, Africa. These epicontinental seas teemed with life. Shallow, warm, sunlit, perfect conditions for productivity. The Western Interior Seaway split North America in half. From the Gulf of Mexico to the Arctic Ocean, 1,000 kilometers wide in places. Fish, sharks, mosasaurs, plesiosaurs, huge predators patrolled these waters. In what is now Kansas, Wyoming, Montana, fossils of marine reptiles are found in prairie fields. Farmers plow them up. Museums collect them. The ocean once covered the heartland. Hard to imagine, but the rocks remember. Chalk formed in the Cretaceous, the famous White Cliffs of Dover, made entirely of tiny shells. Coccolithophorus, microscopic algae that produce calcium carbonate plates. When they die, the plates sink, accumulate on the sea floor. Over millions of years, they compact into chalk, pure white, soft, crumbly. The White Cliffs are graveyards, trillions of microscopic organisms, stacked, compressed, turned to stone. You can write with them. Ancient life, captured, useful, even in death. The Cretaceous ended with a catastrophe. 66 million years ago, an asteroid, 10 kilometers wide, struck Mexico. The Chicxulub impact, energy equivalent to 10 billion Hiroshima bombs, vaporized rock, ejected into the atmosphere. The sky darkened, sunlight blocked, for months, maybe years. Photosynthesis stopped. Then the zooplankton that ate them, then fish, then marine reptiles. 75% of species went extinct. The ocean emptied again, but some survived. Sharks, crocodiles, turtles, some fish. Why? Partly luck, partly resilience. Sharks are scavengers. They can go months without food. When the ocean died, they fed on the dead, survived the darkness. Crocodiles can slow their metabolism, enter a state of torpor, wait out hard times. Turtles bury eggs on land. Even if adults died, hatchlings could emerge years later, repopulate. Survivors have strategies, adaptations that seem minor until catastrophe strikes. Then they're everything. The Cenozoic Ocean, the age of mammals, was different. Cooler ice returned to the poles. Marine mammals evolved. Whales, dolphins, seals, sea lions, manatees, all descended from land mammals that returned to the ocean, just like ichthyosaurs and plesiosaurs before them. Evolution repeats. When a niche exists, something fills it. Legs become flippers. Nostrils migrate to the top of the head. Hair is lost. Blubber develops. The ocean shapes all who enter. The first whales appeared 50 million years ago. They looked nothing like modern whales. Pakicetus, the earliest known whale, had legs. 4 of them. It could walk on land, but it hunted in water, wading, ambushing fish like a crocodile. Over millions of years, its descendants became more aquatic. Legs shrank, tails developed flukes, nostrils moved backward. By 35 million years ago, whales were fully aquatic, streamlined, massive, masters of the ocean. The largest animal ever to exist lives today. The blue whale, 30 meters long, weighing 200 tons, larger than any dinosaur, larger than any marine reptile. The ocean can support such size because water provides buoyancy. On land, bones would crush under their own weight, but in water, whales float, effortless. They feed on krill-tiny shrimp-like creatures, the largest animal eating some of the smallest, filtering tons of water, straining out food. Elegant simplicity. Blue whales sing songs that travel thousands of kilometers. Low-frequency calls, below human hearing, but detectable by hydrophones. These songs cross ocean basins, whale to whale, across the vast dark. We don't fully know what they're saying. Mating calls, territory, navigation. The ocean keeps secrets, even from us. Even with all our technology, some mysteries remain. 20 million years ago, the ocean cooled significantly. Antarctica froze. The Antarctic Circumpolar Current formed, isolating Antarctica, preventing warm water from reaching it. Ice sheets grew, locked up water. Sea levels dropped. Coastal areas expanded. The climate became more seasonal. Distinct winters and summers. Life adapted or went extinct. Those that remained were hardy, tolerant of change, flexible. The Mediterranean Sea disappeared 5.9 million years ago, completely. The Strait of Gibraltar closed. Tectonic movements. No water flowed in from the Atlantic, but the Mediterranean continued to evaporate. Within 1,000 years, it was dry, a desert, 4 kilometers below sea level, the deepest, hottest, driest place on Earth. Salt flats, baking heat, uninhabitable. This event is called the Messinian Salinity Crisis. For 600,000 years, the Mediterranean basin was dry. Rivers from Europe and Africa flowed into it, carved deep canyons. The Nile cut a gorge deep enough that its base was 2,400 meters below current sea level, now buried under sediment. But seismic imaging reveals it, a ghost canyon, hidden beneath modern river deposits. Then, 5.3 million years ago, the Strait of Gibraltar reopened. The Atlantic poured in. The basin refilled in less than 2 years. A waterfall 1,000 times larger than Niagara, thundering, unstoppable. Imagine witnessing that, standing on the shore of the rising sea, watching the desert flood. The ancient Tethys Ocean closed about 5 million years ago. It had existed for hundreds of millions of years, separated Africa from Europe and Asia. But as Africa drifted north, the ocean shrank. The Mediterranean is a remnant, a puddle left behind. The Alps, the Himalayas, the Zagros Mountains, all formed from the collision of continents. Where the Tethys Ocean once flowed, mountains now rise. Ocean floor became mountaintop. Marine fossils are found at 8,000 meters elevation on Everest. The ocean and the mountains trade places. Over millions of years, the cycle continues. 2 million years ago, the ice ages began. Not a single freeze, multiple cycles. Ice advanced, covered Canada, northern Europe, parts of Asia, then retreated. Warmer periods, called interglacials, then advanced again. At least 17 major glaciations, each one lasted tens of thousands of years. Sea levels rose and fell by 120 meters. Coastlines shifted dramatically. Animals migrated, following the climate, or went extinct when they couldn't. During ice ages, the ocean was different. Colder, saltier. So much water was locked in ice that ocean salinity increased. Circulation patterns changed. The deep ocean became colder, more oxygenated. Marine life adapted or moved. Tropical species retreated to the equator. Cold water species expanded. Then the ice melted. Warm species returned back and forth, following the temperature. Migration on geological timescale. Coral reefs collapsed during ice ages, too cold, but they returned during warm periods, rebuilt. The Great Barrier Reef is only 8,000 years old in its current form, built since the last ice age ended. Coral polyps, generation after generation, building, dying, building again. 8 millennia. That seems ancient, but it's recent. Geologically speaking, the ocean renews itself constantly. When the ice melted, sea levels rose rapidly, about 1 meter per century. Coastlines flooded, valleys became bays, hills became islands. The Black Sea filled, a freshwater lake before. Then the Mediterranean breached a natural dam. Salt water poured in. The lake became a sea. Rapidly, catastrophically, for those living on its shores. Evidence of drowned settlements, underwater, preserved. Some archaeologists think this event inspired flood myths. Noah's flood, Gilgamesh, universal deluge stories. Perhaps not universal, but locally. 8,000 years ago, Doggerland connected Britain to Europe. A low-lying plain. Rivers, forests, animals, people lived there. Hunter-gatherers, fishing, hunting mammoth. Then the ice melted, sea levels rose, Doggerland flooded. Britain became an island. The North Sea swallowed a country. Fishermen occasionally dredge up mammoth bones, stone tools, antlers, from the seafloor, from a vanished land. Atlantis is fiction, but Doggerland was real, and it drowned. The ocean today contains 1.335 billion cubic kilometers of water. That's enough to cover the entire Earth to a depth of 2,700 meters if spread evenly. But it's not spread evenly. Ocean basins are deep, continents rise high. The average ocean depth is 3,688 meters. The deepest point, the Mariana Trenches, 10,994 meters. If Mount Everest were dropped into the Mariana Trench, its peak would still be 2 kilometers underwater. The ocean is deep. Deeper than mountains are tall. The ocean floor is not flat, it's mountainous. Mid-ocean, ridges underwater, mountain chains circle the globe. 65,000 kilometers long, longer than any mountain range on land. The Mid-Atlantic Ridge runs down the center of the Atlantic Ocean, separating the Americas from Europe and Africa. New ocean floor forms there. Magma rises, cools, solidifies, spreads. The Atlantic grows wider, a few centimeters per year, slowly, imperceptibly, but constantly. Hydrothermal vents dot the ocean floor. Cracks in the crust where seawater seeps down, gets heated by magma, rises back up. Superheated water over 400 degrees Celsius gushes out. Black smokers, white smokers, depending on mineral content. These vents support unique ecosystems, tube worms, giant clams, eyeless shrimp, all living without sunlight. Chemosynthesis instead of photosynthesis. Bacteria convert chemicals from the vents into energy. They're the base of the food web. Everything else feeds on them, or feeds on things that feed on them. Life at hydrothermal vents is bizarre. Tube worms have no mouth, no gut. They absorb nutrients directly through their tissues. Bacteria living inside them do the digesting. Symbiosis, mutual dependence. The worm provides shelter. The bacteria provide food. Neither could survive alone. Together they thrive. Evolution creates partnerships when it benefits both parties. The deepest fish ever recorded was at 8,178 meters. A snailfish, pale, translucent. It looks fragile, but it's adapted to crushing pressure. Water doesn't compress much, so pressure equalizes inside and outside the fish, no problem. But the chemistry of life changes under pressure. Proteins denature. Membranes fail. Below about 8,500 meters, fish can't survive. Their cells stop working. That's the absolute depth limit for fish. Below that, only invertebrates, amphipods, sea cucumbers, creatures with simpler physiology. The ocean is layered, not just by depth, but by temperature, salinity, density. The surface, layered down to about 200 meters, swarmed by the sun, mixed by wind. Below that, the thermocline zone of rapid temperature decrease. Water gets colder quickly. Below 1,000 meters, the deep ocean, cold, dark, stable. Temperature hovers just above freezing. Most of the ocean's volume is deep ocean, cold and dark. Yet it's full of life, slow-moving, adapted, thriving in the eternal night. The ocean has rivers within it, ocean currents. The Gulf Stream carries warm water from the Caribbean to northern Europe. At its peak, it moves 150 million cubic meters per second. That's 150 times more than all the rivers on land combined. It's a river of warmth. Without it, Britain's climate would resemble Canada's. Ocean currents regulate global climate, distribute heat, connect ecosystems. Larvae of marine species drift in currents, traveling thousands of kilometers, connecting distant populations. The ocean is one. The ocean has deserts, not sandy, but biological deserts. Large regions, especially in the centers of ocean basins, have very low productivity. Clear blue water, beautiful but nearly empty, too far from nutrients. Rivers carry nutrients to coasts. Upwelling brings nutrients from the deep. But the open ocean centers are isolated. Nutrients sink. Light stays at the surface. The two don't meet, so phytoplankton can't thrive. Without phytoplankton, the food web collapses. These are the oceanic equivalents of the Sahara, vast. But even deserts have oases. Seamounts, underwater mountains rise from the deep. Their slopes cause upwelling. Deep, nutrient-rich water rises, meets sunlight, phytoplankton blooms. Fish congregate, sharks patrol. Seamounts are biodiversity hotspots, islands of life in a biological desert. There are over 100,000 seamounts in the ocean, most unmapped, unexplored, each one a potential ecosystem. We know so little. The ocean keeps its secrets. The ocean is salty, obviously. But why? Rivers carry dissolved minerals from land: sodium, chloride, calcium, magnesium. These accumulate in the ocean. Water evaporates. Salt stays behind. Over billions of years, the ocean became salty. About 3.5% salt, 35 grams per liter. Enough to taste, enough to preserve. Sailors in the past drank rum and rainwater. Never ocean water. It dehydrates you. Kidneys can't process that much salt. You die of thirst, surrounded by water. But ocean salinity isn't uniform. Near river mouths, it's lower. Fresh water dilutes the salt. In the Red Sea and Persian Gulf, salinity is higher, high evaporation, restricted circulation. In the Baltic Sea, salinity is very low. Lots of river input, limited connection to the salty Atlantic. Salinity affects buoyancy. High salt water is denser. Objects float better. The Dead Sea, technically a lake, is so salty you can't sink. You bob like a cork, reading a newspaper while floating. Physics, not magic. The ocean is blue, but why? Water absorbs red light. Long wavelengths. Blue light shorter. Wavelengths scatters. Like the sky, in shallow water, other colors are visible. Green from algae, brown from sediment. But in deep, clear water, only blue remains. Pure, endless. That's why tropical waters are so vividly blue. Clear water, deep. Nothing to scatter the light except water molecules themselves. The ocean's color is physics, simple, beautiful, profound. The ocean produces 50% of the oxygen we breathe, not from whales, not from fish, from phytoplankton. Microscopic algae drifting in sunlight, photosynthesizing, converting CO2 and water into sugars and oxygen. Every second breath you take comes from the ocean, specifically from organisms you can't see, will never see, don't even know exist. But you depend on them, absolutely, the invisible majority, keeping the world alive. Phytoplankton blooms are visible from space. Swirls of green and turquoise. Satellite images show them, spreading across hundreds of kilometers. These blooms feed the ocean. Zooplankton eat phytoplankton. Fish eat zooplankton. Larger fish eat smaller fish. Whales eat everything. The food web starts with the smallest. The foundation, invisible but essential. Damage the phytoplankton, and the ocean collapses from the bottom up. Everything depends on the base. The ocean stores heat. Vast amounts. Water has a high heat capacity. It takes a lot of energy to warm it. The top 3 meters of the ocean store as much heat as the entire atmosphere. That's why coastal areas have mild climates. The ocean moderates temperature, warm in winter, cool in summer. Compared to inland areas, the ocean is Earth's thermostat, slowing change, stabilizing climate. Without it, temperature swings would be extreme, deserts would be hotter, winters colder. The ocean makes Earth habitable. But the ocean is warming, has been for decades, absorbing 90% of excess heat from global warming. This has slowed atmospheric warming, but at a cost. Warmer water holds less oxygen. Marine life suffocates, coral bleaches, fish migrate to cooler waters, food webs destabilize. The ocean is changing faster than it has in millions of years. Life will adapt, eventually, but adaptation takes time, and we're changing things quickly, too quickly for many species. Coral reefs are dying. Not everywhere, not all of them, but many. 30% of reefs have been severely damaged. Another 30% are under threat. Warmer water stresses coral. They expel their symbiotic algae, lose their color, bleach. Without algae, coral slowly starves. If temperatures cool, they can recover. Algae return, color returns. But if stress continues, coral dies. The reef crumbles, becomes rubble. Fish leave. The ecosystem collapses. But some reefs are resilient, adapted to temperature swings. In the Red Sea, corals tolerate temperatures up to 34 degrees Celsius, far above normal. They've evolved heat resistance. Scientists are studying them, trying to understand how. Can this resilience be transferred? Can we help other reefs adapt? Hope exists, not certainty, but possibility. Nature is creative. Given time and chance, it finds solutions. The ocean has absorbed 30% of human CO2 emissions since the Industrial Revolution. This has slowed atmospheric CO2 buildup, delayed climate change. But CO2 dissolves in water, forms carbonic acid. The ocean is acidifying, pH dropping, slowly but measurably. This affects shell-building organisms, mollusks, corals, plankton. Their shells dissolve or fail to form properly. It's harder to build calcium carbonate structures in acidic water. Chemistry, inexorable. The ocean's chemistry is changing, and with it, life. But the ocean is vast. Changes take time. Even if we stopped all emissions today, the ocean would take centuries to recover. Momentum, inertia. The ocean is slow to warm, slow to cool, slow to acidify, slow to neutralize. That's good and bad. Good because it gives us time, bad because changes persist. What we do now affects the ocean for centuries. Our great-great-grandchildren will inherit the ocean we're creating. Responsibility, stewardship, these aren't abstract. They're real, tangible, written in water. Yet the ocean endures. It always has. Through asteroid impacts, volcanic eruptions, ice ages, mass extinctions, the ocean survives. Life survives. Maybe not the same species, maybe not the same ecosystems, but life continues, adapts, evolves, fills the niches. The ocean is patient. It operates on timescales we can barely comprehend. Millions of years, tens of millions. We're just one moment in its long history, one breath in an endless song. The ocean has memory, not consciousness, but physical memory. Deep ocean currents carry water from the surface down. In the polar regions, where cold, dense water sinks, this water retains the chemical signature of the atmosphere when it sank. Scientists can analyze it, determine when it left the surface. Some deep water is 1,000 years old. Water that sank during the Middle Ages, before Columbus, before printing presses. That water is still circulating, slow, patient, carrying medieval chemistry through the abyss. The ocean breathes, metaphorically. Dissolved oxygen enters at the surface. Through wave action, photosynthesis, then sinks with cold water, distributed throughout the depths. Without this ventilation, the deep ocean would be anoxic, oxygen-free, lifeless, but currents circulate, mixing, oxygenating. The ocean's circulation is like Earth's breathing, slow, deep, sustaining life in the darkest places. The ancient Iapetus Ocean closed 400 million years ago. It once separated what are now North America and Europe. When it closed, the continents collided. Mountains rose, the Appalachians, the Scottish Highlands, the Norwegian mountains. These ranges were once connected, one continuous chain, before the Atlantic opened and separated them. You can match rock types across the ocean. Same age, same minerals, same fossils. The mountains, remember, even though the ocean that created them is gone. Mountain ranges mark where ancient oceans closed. The Urals, the Appalachians, the Alps. Each one is a scar, a suture, where continents collided and ocean crust was destroyed. Look at a mountain range, and you're seeing the grave of an ocean. Water that once covered the space between continents, now squeezed out, gone, replaced by rock pushed skyward. Oceans don't last forever. They open, widen, close, disappear. The cycle continues. The Rheic Ocean existed between Gondwana and Laurasia 500 to 300 million years ago. It was wide at its peak, thousands of kilometers, separating the southern continents from the northern. Unique marine life evolved on each side, isolated, different. Then the ocean closed. The continents united into Pangaea supercontinent. Marine species that had evolved separately were suddenly neighbors. Some competed, some went extinct. The fossil record shows this turnover. Old species disappearing, new ones spreading. Geography controls evolution. Open an ocean, life diverges. Close an ocean, life merges. Asterisk, asterisk. Pangaea assembled 300 million years ago. All continents joined. The Panthalassic Ocean surrounded it. A global ocean, vast beyond imagination, covering 70% of Earth's surface, larger than all modern oceans combined. The waves must have been enormous. Storms unimpeded for thousands of kilometers. Fetch the distance wind can blow across open water determines wave size. Longer fetch, bigger waves. In the Panthalassic, fetch was limitless. Waves could build across entire hemispheres. Monstrous swells, higher than buildings, crashing onto the shores of Pangaea. The Tethys Ocean opened as Pangaea rifted 200 million years ago. A wedge-shaped sea between Africa and Europe, growing wider, tropical, warm, shallow in places, deep in others. Life thrived there. Ammonites, marine reptiles, coral reefs. For 150 million years, the Tethys was the dominant ocean basin. Then it closed. Africa drifted north. The Mediterranean is what's left. A remnant, a memory. Most of the Tethys seafloor is now gone, subducted, destroyed, or uplifted into mountains. You can find Tethys fossils in the Himalayas, marine shells, coral, ammonites, at 8,000 meters elevation, where climbers gasp for air, where snow never melts. These fossils formed underwater in warm, shallow seas. Then tectonic forces lifted them higher than any ocean ever reached, from seafloor to mountaintop. The ultimate journey. Geology rewrites geography. What was low becomes high. What was water becomes rock. Nothing is permanent. The Paratethys Sea covered much of Europe and Asia 34 to 11 million years ago. An inland sea, sometimes connected to the ocean, sometimes isolated. During isolation, it became brackish. Salinity fluctuated. Species evolved in response. Unique fish mollusks found nowhere else. Then the paratethys dried up, mostly. The Black Sea, Caspian Sea, Aral Sea, these are remnants, isolated pools, all that remains of a once great sea. The Atlantic Ocean is young, in geological terms. It began opening 200 million years ago, when Pangaea rifted. North America separated from Africa, South America from Europe. A narrow rift at first, like the Red Sea today. Then wider, deeper. As new ocean floor formed, the Atlantic is still growing, a few centimeters per year. In 50 million years, it will be significantly wider. The continents continue to drift. Earth's surface never rests. The Pacific Ocean is shrinking, has been for millions of years. Subduction zones ring its edges. Ocean crust diving beneath continents. The Ring of Fire. The Pacific is the remnant of the Panthalassic Ocean, much older than the Atlantic, but getting smaller. Eventually, hundreds of millions of years from now it may close completely. Then a new supercontinent will form. All landmasses united again. The cycle completes and begins anew. The Indian Ocean formed when India broke from Gondwana 140 million years ago. India drifted north, slowly, a few centimeters per year, crossing thousands of kilometers. For 90 million years, it was an island continent, isolated. Unique species evolved. Then India collided with Asia. The Himalayas rose. The Indian Ocean shrank slightly, but remains the youngest of the major oceans, born from breakup, shaped by collision. Ancient oceans had different chemistry, not just salinity, but composition. The Archean Ocean 4 billion to 2.5 billion years ago contained more dissolved iron, much more. When oxygen arrived, iron precipitated, banded iron formations, red layers of rust. The ocean's color might have been greenish, iron-rich, oxygen-poor, not blue, not inviting, not anything like today's seas. A chemical soup, hospitable to life then, toxic to life now. The Proterozoic Ocean 2.5 billion to 541 million years ago was purple, possibly. Photosynthetic bacteria used different pigments than modern plants, retinol instead of chlorophyll. These pigments absorb green light, reflect red and blue, making them appear purple. If they dominated the ocean, the water might have looked purple from space. We don't know for certain, but models suggest it. A purple ocean under an orange sky. Earth was alien, even to itself. The Cambrian Ocean was clear. Probably early animals hadn't evolved sediment-stirring behaviors, burrowing, digging. The seafloor was smooth, microbial mats, little disturbance. Sediment stayed settled. Water above was crystal clear. Then burrowers evolved, worms, arthropods. They churned the sediment. Biorbation, it's called, mixing layers, suspending particles. The ocean became cloudier, more nutrient-rich, more productive. Life made the ocean murkier, but also more fertile. The Devonian period is called the Age of Fishes. 419 to 359 million years ago, fish diversified explosively. Jawed fish, armored fish, lobe-finned fish, ray-finned fish. Some grew enormous. Dunkleosteocene, armored fish reached 10 meters long. Its jaws were bony plates, sharp edges, shearing force. It could bite through anything. Apex predator, terror of the Devonian seas, but it went extinct. Like most Devonian fish, mass extinction at the period's end. Reefs collapsed. Oxygen levels dropped. 75% of species died. Another reset. Another opportunity for survivors. Lobe-finned fish gave rise to tetrapods, four-limbed vertebrates, fish with muscular, fleshy fins. They could prop themselves up, breathe air, move through shallow water and onto land. 375 million years ago, Tiktaalik, transitional form, lived in streams. It had gills and lungs, fins and protolimbs. It was neither fully fish nor fully tetrapod, it was both. And it was the ancestor of all land vertebrates, amphibians, reptiles, mammals. You descended from a fish, one that learned to walk. The Carboniferous Ocean was oxygen-rich 359 to 299 million years ago. Oxygen levels reached 35%, compared to 21% today. This allowed gigantism on land, giant dragonflies, millipedes a meter long, but in the ocean too. Arthropods grew larger, fish grew larger. High oxygen supports high metabolism, more energy, bigger bodies. Then oxygen levels dropped, giants shrank or went extinct. Size depends on environment. Change the environment, change the size. Sharks are older than trees. Let that sink in. Sharks evolved 450 million years ago. Trees evolved 385 million years ago. Sharks have been around 65 million years longer. They've survived 5 mass extinctions, outlasted dinosaurs, outlasted countless species. Why? Adaptability, simple body plan, efficient predators. They don't need to change much. Evolution refined them early. The design works. Modern sharks are little different from ancient sharks. Success doesn't require innovation. Sometimes it requires persistence. Megalodon, the giant shark, went extinct 3.6 million years ago. It was the largest predatory shark ever. 18 meters long, teeth the size of a human hand. It ate whales. Bite marks on fossil whale bones prove it, but it vanished. Why? Unclear. Climate change, prey, migration, competition with orcas. We don't know for certain, but the ocean's apex predator disappeared. Even apex predators aren't immortal. Even perfection can fail when conditions shift. The Pleistocene ocean 2.6 million to 11,700 years ago was colder. Ice ages dominated. Sea levels dropped. Coastlines expanded. Shallow seas drained. Coral reefs contracted. Marine species migrated, then warmed. Ice melted. Coastlines flooded. Reefs expanded. Species returned. This happened repeatedly, at least 17 times. Life had to adapt to instability, constant change. Survival meant flexibility, mobility, resilience. The species that thrived were generalists, adaptable, tolerant. Specialists went extinct, unable to cope with shifting conditions. Humans evolved during the ice ages. Our ancestors walked across land bridges between Asia and Australia, between Asia and North America. The Bering Land Bridge connected Siberia and Alaska. Humans crossed it, entered the Americas. 15,000 years ago, maybe earlier. They followed megafauna, mammoths, bison, giant sloths, hunted them, relied on them. Then the ice melted. The land bridge flooded, the Bering Strait opened, populations were separated, isolated, diverged. The ocean shapes human history as much as land. Ancient seafarers crossed vast oceans with primitive technology. Polynesians colonized the Pacific island by island in outrigger canoes, no compasses, no maps, just stars, waves, currents. bird behavior. They read the ocean, felt it, understood it. They reached Easter Island, Hawaii, New Zealand, thousands of kilometers from their origin. How knowledge passed down orally, generation to generation. The ocean was their highway, not a barrier, a pathway. Perspective matters. The ocean has always been a highway for species, for cultures, for genes. Ocean currents carry larvae, plankton, seeds, floating debris. Species that live on opposite sides of an ocean can be genetically connected if their larvae drift in currents, gene flow across thousands of kilometers. The ocean unites as much as it separates. Barriers are relative. What seems impassable to us is a highway to others. Kelp forests are ancient ecosystems. Kelp giant brown algae can grow 0.5 meter per day, faster than any other organism on Earth. From bare rock to towering forest in months, kelp holdfasts anchor them, not roots, just sticky attachments. They don't need soil, just rock, sunlight, nutrients. Kelp forests stretch along temperate coasts, providing habitat for fish, invertebrates, sea otters. Remove the kelp, and the ecosystem collapses. Foundation species, everything depends on them. Sea otters control kelp forests. Indirectly, they eat sea urchins. Sea urchins eat kelp. Without otters, urchins multiply. They overgraze. Kelp forests turn into urchin barrens. Bare rock, no habitat. But when otters return, they eat urchins. Kelp regrows. The forest returns. This is a trophic cascade. Top predators control entire ecosystems, not just their prey, but the prey's prey, and so on. Connections, dependencies. The web of life is intricate, fragile, resilient. Whales engineer ecosystems, their bodies, their behavior. When they dive, they feed deep, then return to the surface, defecate. Whale feces rich in nutrients fertilizes surface waters. Phytoplankton blooms. Fish follow. Whales create productivity. They pump nutrients from the deep to the surface. The whale pump, scientists call it. Without whales, nutrient cycling slows. Fewer whales mean less productivity. Even though whales eat fish, paradoxically, they increase fish populations by fertilizing the ocean. Nature is counterintuitive. When a whale dies, its body sinks, becomes a whale fall. Tons of organic matter delivered to the deep seafloor. Scavengers arrive. Hagfish, sleeper sharks. They strip the flesh. Then bone-eating worms, Osedax. They burrow into whale bones. Asterisk extract lipids. A whale fall can support a unique ecosystem for decades. Bacteria, worms, crustaceans, life feeding on death. The cycle continues. Even in the abyss, nothing is wasted. Everything is recycled. The ocean has zones, not just depth, but light. The euphotic zone's sunlight penetrates down to about 200 meters. Photosynthesis occurs. The dysphotic zone, twilight zone, 200 to 1,000 meters. Dim light, no photosynthesis, but enough to see. The aphotic zone, total darkness, below 1,000 meters, no sunlight, ever. Most of the ocean is aphotic, dark, cold, pressurized, yet full of life. Life doesn't need light, it needs energy. And energy exists in many forms. Bioluminescence is common in the deep sea. 90% of deep sea animals produce light, not from sunlight, from chemistry. Luciferin molecules react with oxygen, catalyzed by luciferase enzymes. Light is released. Blue-green usually travels farthest in water. Why bioluminescence? Attract prey, confuse predators, communicate, find mates. The deep ocean twinkles. not empty, not silent, just invisible to us. A light show in the abyss, happening constantly. The giant squid Darkatoothus lives in the deep ocean, up to 13 meters long, eyes the size of dinner plates, the largest eyes in the animal kingdom. Why so large? To capture every photon in near total darkness. Giant squid and sperm whales battle. Squid tentacles found on whale skin, squid beaks found in whale stomachs. Whales dive deep, hunt squid, sometimes win, sometimes lose. We've never witnessed this battle, only seen the evidence. The ocean keeps its dramas private. The colossal squid is even larger, maybe asterisk 14 meters, estimated, heavier body, larger beak, hooks on its tentacles, found in Antarctic waters, deep, cold. Only a few specimens captured, mostly incomplete. We don't know how they live, how they hunt, how they reproduce. The ocean's giants remain mysterious, despite satellites, despite submarines. Some things still hide, even from us. The ocean is loud, underwater. Whales sing, dolphins click, shrimp snap. Snapping shrimp, tiny creatures, create the loudest sound for their size. They close their claws so fast it creates a cavitation bubble. The bubble collapses. Shockwave stuns prey. The sound reaches 210 decibels, louder than a gunshot. Millions of snapping shrimp create a constant crackling in shallow tropical waters. Submarines use this noise as camouflage, hiding in the symphony of snaps. Sound travels faster in water, about 5 times faster than in air, 1,500 meters per second, compared to 343 meters per second in air. Whales use this. Their calls travel hundreds of kilometers. Before human noise pollution, whale songs might have circled the globe, traveling through ocean channels. Now, ship engines, sonar, construction. The ocean is noisy. Human-made noise, drowning out natural sounds. Whales have to sing louder, adjust their frequencies, or stop singing. We've made the ocean harsh, even in ways we don't see or hear. The ocean has memory of sound, not recording, but channels. So far channels, sound, fixing, and ranging channel. A layer about 1,000 meters deep where sound waves bend, trapped between layers of different density. Sound can travel thousands of kilometers with minimal loss. Whales use this channel. Their calls propagate farther, more efficiently. During the Cold War, the U.S. Navy monitored this channel, listening for Soviet submarines, but they heard whales instead. Songs traveling across entire ocean basins. The ocean carries whispers from continent to continent. If you know how to listen, ancient sailors navigated by sound. In fog, darkness, they listened for waves breaking on shore. Different coasts sound different. Rocky shores crash, sandy beaches whoosh. Experienced sailors could identify locations by sound alone. They rang bells, listened for echoes, measured time, calculated distance. Before radar, before GPS, just ears, experience. The ocean speaking to those who knew its language. We've lost this knowledge mostly, but it was once essential. The ocean taught humans, if they were willing to learn. The Sargasso Sea has no coastline, entirely bounded by currents. In the North Atlantic, where ocean circulation creates a still zone, floating mats of sargassum seaweed, brown, tangled, stretching for kilometers. These mats are ecosystems. Fish hide in them, seahorses cling to them, sea turtles rest on them. The Sargasso is both desert and oasis, low nutrients below, but life concentrated at the surface. Eels migrate there, from rivers across Europe and North America, to breed, then die. Nobody has witnessed eel spawning. We know they go there, but we've never seen it happen. The ocean keeps secrets, even well-studied ones. JRs circulate ocean water. 5 major ones: North Atlantic, South Atlantic, North Pacific, South Pacific. Indian Ocean, rotating slowly, driven by wind and Earth's rotation. The Great Pacific Garbage Patch sits in the North Pacific Gyre. Trash accumulates: plastic, fishing, nets, debris. The patch isn't a solid island. It's more like a soup. Particles suspended, drifting, concentrating, covering an area twice the size of Texas, maybe larger, hard to measure. We created it, carelessly, thoughtlessly. The ocean accepted our waste for decades, but now it's full. The ocean has limits. We're discovering them the hard way. Microplastics are everywhere in the ocean. Tiny fragments, less than 5 millimeters, broken down from larger pieces by waves. Sunlight, time, fish eat them, thinking they're plankton. Seabirds feed them to chicks. Sea turtles ingest them. Microplastics are found in the deepest trenches, the most remote waters, even Arctic ice. We've polluted every corner. In just 70 years since plastic became common, the ocean is resilient, but not infinitely. Plastic doesn't biodegrade, not on human timescales. It fragments, but never disappears. Our waste is now part of the ocean's fabric, woven in, persistent. But the ocean can heal if we let it. When fishing pressure decreases, fish populations rebound, sometimes rapidly. Humpback whales were hunted nearly to extinction. By the 1960s, fewer than 5,000 remained. Then hunting stopped. Populations grew. Now over 80,000. Not recovered entirely, but recovering. The ocean wants to thrive. Life wants to proliferate. We just have to step back, give space, give time. Nature does the rest. Mangrove forests grow where ocean meets land. In tropical and subtropical zones, trees with roots in salt water, tolerating what most plants can't. Mangroves protect coastlines. Their roots absorb wave energy, prevent erosion. They filter water, trap sediment, improve clarity. They're nurseries for fish, crustaceans. Juvenile creatures hide among the roots, protected, fed. Remove mangroves, and coastlines erode. Fish populations decline. Storm damage increases. Mangroves are worth more alive than dead, economically, ecologically, obviously. Yet, we've lost half of them, globally, cleared for development. Aquaculture, the ocean's edges fray when we cut its fringe. Salt marshes serve similar roles. In temperate regions, grasses tolerant of tides, twice daily flooding, exposure. These marshes sequester carbon, store it in soil, more efficiently per area than forests. Blue carbon, it's called. Carbon captured by coastal ecosystems. Salt marshes, mangroves, seagrass beds. Together, they store enormous amounts. Destroy them, and carbon releases into the atmosphere, contributing to warming. Protect them, and carbon stays locked away. For centuries, millennia, coastal ecosystems are climate solutions. If we let them be, seagrass, meadows, carpet, the shallow seafloor, not seaweed, actual flowering plants. They evolved on land, then returned to the ocean, like whales, like sea turtles. Seagrasses have roots, leaves, flowers. They photosynthesize, produce oxygen. They stabilize sediment, prevent resuspension, keep water clear. They feed marine life directly. Sea turtles graze on them. Dugongs, manatees, indirectly. Detritus feeds countless organisms. Seagrass meadows support biodiversity, equivalent to coral reefs, but less celebrated, less protected. They're disappearing. Dredging, pollution, coastal development. 7% of seagrass meadows lost per year. Globally, unsustainable. Tragic. The ocean's meadows are burning, metaphorically, but no less real. The ocean produces distinct sounds by region. Marine biologists call them soundscapes. Coral reefs crackle. Fish, shrimp, urchins all making noise. A healthy reef is loud. A dying reef is silent, eerie, empty. Whales create different soundscapes depending on species, season. Snapping shrimp dominate tropical shallows. Their collective snapping creates a constant hiss. Ice cracking sounds dominate polar regions. Creaking, groaning, explosive cracks. Each habitat has a signature, a sonic fingerprint. Marine animals navigate by sound, recognize home, avoid danger. When we change the soundscape, we disorient them, lost, confused, unable to find their way. The ocean has seasons, not like land, but cycles. Phytoplankton blooms in spring. When sunlight strengthens, nutrients rise. Zooplankton follows, eating the phytoplankton. Fish follow the zooplankton. Whales follow the fish, each trophic level responding to the one below. A cascade, predictable, ancient, but climate change is shifting these cycles. Blooms happen earlier or later. Animals that time migrations to blooms arrive too early or too late. Food isn't there. Timing is everything. Disrupting timing disrupts the entire food web. The ocean has internal waves, not on the surface, between layers of different density. Deep water, surface water. These internal waves can be 100 meters tall, larger than surface waves, but invisible from above, only detectable by instruments. They move slowly, a few kilometers per hour, but they transport nutrients, energy, heat, mixing the ocean, connecting surface and deep. Submarines encounter them. Sudden depth changes, like underwater weather. The ocean has hidden dynamics. Visible water is only part of the story. Asterisk, asterisk. Rogue waves appear without warning. Massive, steep walls of water 30 meters high, towering above surrounding swells. For centuries, sailors reported them. Scientists dismissed them as myths. Rogue waves exist. They form when multiple wave trains converge. Constructive interference. Energy concentrates. A single monstrous wave. Then it dissipates. Rogue waves have sunk ships, damaged oil rigs, killed sailors. The ocean still surprises us, still holds dangers we can't predict. Tsunamis are not surface waves. They're displacement waves, caused by underwater earthquakes, landslides, volcanic eruptions. The entire water column moves, from seafloor to surface. In deep ocean, tsunamis are barely noticeable, maybe a meter high, moving 800 kilometers per hour. But as they approach shore, they slow. Shallow water compresses them. Energy concentrates. Height increases. 10 meters, 20, 30. A wall of water, unstoppable. The ocean floor, displaced. The ocean responds with devastating force, not malice, just physics, momentum, gravity. The ocean doesn't intend harm, but it's powerful, indifferent, capable of reshaping coastlines in minutes. The 2004 Indian Ocean tsunami killed 230,000 people, the deadliest in recorded history, triggered by a 9.1 magnitude earthquake off Sumatra. The ocean floor ruptured, lifted, displacing trillions of tons of water. Waves radiated outward, reaching shores across the Indian Ocean, Indonesia, Thailand, Sri Lanka, India, even Africa. No warning system existed then. People didn't know to run. The ocean teaches harsh lessons, but we learn. Now early warning systems exist. Sensors, buoys, alerts, saving lives. Knowledge is power. Preparation is survival. The ocean's surface layer is called the mixed layer. About 100 meters deep, stirred by wind, warmed by sun. Temperature and salinity are uniform, homogenized. Below this, the thermocline, rapid temperature drop. The mixed layer is where most ocean life concentrates. Sunlight reaches, nutrients mix, photosynthesis happens. Everything else depends on this layer. The ocean's skin, thin, critical, warm, the surface too much, and the mixed layer deepens or becomes stratified. Nutrients don't rise, productivity drops, the ocean's engine sputters. When we heat it, El Niño and La Niña cycle every few years. Changes in Pacific Ocean temperatures. El Niño warm phase. Surface waters warm. Trade winds weaken. Weather patterns shift globally. Droughts in Australia. Floods in California. La Niña cool phase. The reverse. These cycles have always existed, long before humans. Ancient cultures recognized them. Peruvian fishermen named El Niño, the Christ child, because it often arrived around Christmas. Warming waters, fewer fish. They noticed, adapted. Now we monitor El Niño with satellites, predicted months in advance, but we can't control it. The ocean does what it will. We can only observe, prepare, respond. The ocean absorbs sound selectively. Low frequencies travel farther. High frequencies attenuate quickly. That's why whales use low-frequency calls to communicate across distance. Blue whales sing at around 20 hertz, below human hearing. Their songs can travel 1,000 kilometers, maybe farther. Before engine noise, possibly much farther, circumnavigating the ocean. Whales were never isolated. Even across vast distances, they could hear each other, stay connected, until we filled the ocean with noise. Now their range is reduced, fragmented. The ocean is crowded, acoustically, even when it looks empty. The midnight zone 1,000 to 4,000 meters deep is the largest habitat on Earth. By volume, completely dark, near freezing, high pressure, yet more animals live here than anywhere else combined. Small fish, jellyfish, squid, shrimp, they migrate vertically, rising at night to feed in surface waters, descending at dawn to avoid predators. The largest migration on Earth by biomass, billions of tons, moving up and down daily. We only discovered this recently. Sonar detected it, a false seafloor that rose and fell. It was life, massive schools, hidden in darkness. The ocean conceals more than it reveals. Deep-sea fish have adaptations we're still discovering. Antifreeze proteins in their blood, preventing ice crystal formation in sub-zero waters. They're not frozen, despite the cold, flexible bones, reducing weight. No swim bladder. Pressure equalizes inside and out. No crushing. Giant mouths. Distensible stomachs. They can eat prey larger than themselves. Because food is scarce. Can't be picky. Must take what comes, whenever it comes. Life at depth is about efficiency, minimizing energy use, maximizing opportunity. Every adaptation serves survival. Nothing wasted, nothing ornamental. The ocean's midnight zone is Earth's largest carbon sink. Organic matter sinks from the surface. The biological pump. Phytoplankton photosynthesize, zooplankton eat them. Fish eat zooplankton. When they die, they sink. Fecal pellets sink. Molts sink. Carcasses sink. Carbon that was atmospheric CO2 is now locked in the deep. For centuries, millennia, without the biological pump, atmospheric CO2 would be much higher. The ocean is doing us a favor. Continuously, invisibly, we should be grateful and careful. Disrupt the pump, and carbon stays in the atmosphere. Warming accelerates. Hydrothermal vent ecosystems were discovered in 1977, surprisingly recently. Scientists diving in Alvina submersible near the Galapagos Rift expected barren seafloor, found thriving communities, tube worms, clams, crabs, no sunlight, no photosynthesis, energy from chemicals, hydrogen sulfide, methane, toxic to most life, but bacteria convert them. Chemosynthesis. These bacteria feed the entire ecosystem, the foundation. Life doesn't need sunlight, just energy, in any form. This discovery expanded our understanding of life's possibilities. If life exists here, it could exist on Europa, Enceladus, anywhere with water and chemistry. Vent ecosystems are ephemeral. Vents open, vents close. A vent might be active for decades, then stop. The ecosystem collapses. Animals die or migrate to new vents. But how do they find new vents? Tens of kilometers away, in total darkness. We don't fully know. Chemical cues, maybe, following gradients. Larvae drifting in currents, hoping to find habitat. Survival is chance and adaptation. The ocean's vents are islands, isolated, connected by invisible threads, currents, chemistry, luck. The ocean has underwater lakes, not metaphorical, actual lakes of brine, super salty water, denser than surrounding seawater. It pools in depressions on the seafloor, separate, distinct, with a surface, shores, waves, underwater, organisms that enter die. Too salty, toxic, but around the edges, unique communities, mussels, bacterial mats. These brine pools are ancient, formed when seas evaporated, salt deposits dissolved, concentrated. Visiting them requires submarines, but they exist, hidden, strange. The ocean contains multitudes, layer upon layer, world within world. Cold seeps are like hydrothermal vents, but cold, methane and hydrogen sulfide seep from the seafloor. From deep sediments, bacteria consume these chemicals. Chemosynthesis, again, mussels and clams host these bacteria. Symbiosis, the animals provide shelter, bacteria provide food. Neither can survive alone. Cold seeps are more common than hydrothermal vents, found on continental slopes worldwide, but harder to find. No towering chimneys, no dramatic plumes, just subtle seepage. Life in slow motion, persistent, patient. The ocean has caves, underwater, carved by fresh water. When sea levels were lower, during ice ages, rivers flowed underground, dissolved limestone, created caverns. Then sea levels rose, the caves flooded. Now they're submerged. Blue holes in the Bahamas, cenotes in Mexico. Divers explore them carefully. No light, no air, easy to get lost. But inside, incredible formations. Stalactites, stalagmites, formed in air, now underwater, preserved, frozen in time. The ocean absorbs the land's past and keeps it. Shipwrecks become reefs, artificial but functional. Within months, organisms colonize. Algae, sponges, corals. Within years, fish arrive, seeking shelter, food. Within decades, the wreck is unrecognizable, covered, transformed. The ocean reclaims everything, given time. Metal corrodes, wood rots, but the structure remains, providing habitat. Intentional artificial reefs use this principle, sinking old ships, concrete modules, creating fish habitat, boosting populations. The ocean doesn't judge, it just accepts, incorporates. The Titanic sits at 3,800 meters on the Atlantic seafloor, sunk in 1912. Over a century ago. Bacteria are consuming it. Rusticles, formations of rust and bacteria. Asterisk, asterisk, dripping from the hull. Eventually, the ship will dissolve, become part of the sediment. But for now, it's a time capsule, preserved by cold, pressure, darkness, visited by submarines, photographed, studied, mourned. The ocean holds our history, whether we want it to or not. Every ship, every plane, every lost object, resting on the bottom, waiting. Over 3 million shipwrecks lie on the ocean floor, estimated, from ancient triremes to modern freighters, spanning millennia. Each one a story, a disaster, a loss, but also a habitat, a monument. Some are war graves, protected, sacred. Others are archaeological sites, excavated, carefully preserved. The ocean is humanity's largest museum, unintended, unorganized, but vast and growing. Every year, ships sink, planes crash. The ocean accepts them all, patiently, silently, becoming reef, becoming history. The ocean floor is mapped less completely than the moon or Mars. Only 20% has been mapped at high resolution. The rest is rough estimates, satellite measurements. We know the general shape, but not the details. Mountains, valleys, canyons, all hidden beneath kilometers of water. Why haven't we mapped it? Cost, difficulty. The ocean is vast. Sonar ships are slow, but efforts continue. Every year, more seafloor revealed. The ocean gradually surrenders its secrets, but slowly, reluctantly. There's still so much to discover on our own planet, in our own time. The deepest fish ever recorded was at 8,178 meters, a snailfish in the Mariana Trench. But the absolute deepest point 10,994 meters has no fish, too deep, pressure too extreme. But amphipods live there, crustaceans, small, hardy, feeding on whatever drifts down from above, marine snow, dead organisms, particles. The very bottom of the ocean is not empty, just sparse, quiet, slow. Life persists, even in the most extreme environment on Earth's surface. If life can exist there, where else might it exist? Under Europa's ice, in Enceladus's geysers. The deep ocean is a test case, proof that life doesn't need light or warmth or comfort, just liquid water and chemistry. The ocean contains an estimated 20 million tons of gold, dissolved, but at concentrations of about 13 parts per trillion, utterly uneconomical to extract. You'd have to process billions of liters to get a single ounce. The energy cost exceeds the value, but it's there, along with every other element. The ocean is a chemical soup. Everything that ever washed off land, everything that ever dissolved from volcanic vents, all mixed together, dilute, but present. The ocean is patient. It accumulates, slowly, over geological time. What seems insignificant becomes substantial. Given enough time, ancient ocean sediments preserve climate history, cores drilled from the seafloor. Each layer represents time, years, decades, centuries, Foraminophora, tiny-shelled organisms, record water temperature. Their shells' oxygen isotope ratios vary with temperature. Analyze the shells, and you reconstruct past climate, going back millions of years. We know Earth's temperature history, ice ages, warm periods, everything written in shells, smaller than grains of sand. The ocean is a library, if you know how to read it. Sediment cores show the asteroid impact 66 million years ago, a thin layer of iridium, rare on Earth, common in asteroids, spread worldwide in seafloor sediments, in rocks. Below the layer, dinosaur fossils. Above it, none. The boundary marks the end, the Cretaceous-Speleogene boundary. It's visible, a line in the rock, a moment in time when everything changed. The ocean remembers, the rocks remember. We read them and understand. What happened when, why? The ocean's chemistry has changed many times. Oxygen levels, acidity, salinity. During the Permian extinction, the ocean became anoxic, oxygen depleted, purple sulfur bacteria bloomed, producing hydrogen sulfide, poisonous. The ocean may have released toxic gas into the atmosphere, killing terrestrial life too. A feedback loop. Volcanic CO2 warmed the planet. Warming destabilized methane hydrates. Methane release warmed further. Ocean circulation collapsed. Oxygen vanished. The ocean became a death trap for 96% of species. But life returned. Eventually, slowly, the ocean healed, as it always does, given time. Methane hydrates, frozen methane, exist on the seafloor, in sediments, at continental margins, enormous quantities, more carbon than all fossil fuels combined, stable at high pressure and low temperature, but warm the ocean and they melt. Release methane, potent greenhouse gas. Warming accelerates. This is called the Clathrate gun hypothesis, a potential tipping point. It may have happened before, during past warming events. Could it happen again? Possibly. Scientists monitor it carefully. The ocean holds many triggers, most stable, a few dangerous. Respect is warranted. The ocean's food web starts with the smallest organisms, phytoplankton, bacteria, but it depends on whales. Large predators remove the whales, and the entire system shifts. Trophic cascade. Fewer whales mean less whale feces, less fertilizer, less phytoplankton, fewer fish, fewer seabirds. Everything connected. Restoring whales restores the ocean, not instantly, but over time. Life rebuilds from the top down and bottom up simultaneously. Complexity emerges. Nature doesn't need instructions, just ingredients, time, space. The ocean's color is changing. Satellite data shows it. Tropical regions are becoming bluer, polar regions greener. Why? Phytoplankton communities are shifting. Warmer water favors different species. Smaller phytoplankton, less productive. Bluer water means less life, clear but empty. Greener water means more productivity, cloudier but fertile. The ocean's color is its health indicator, and it's changing before our eyes. We're witnessing a transformation faster than any natural cycle. The ocean adapts, but we're testing its limits. Yet some changes are positive. Marine protected areas are expanding. 30% of the ocean by 2030 is the goal. Many nations committed. Protected areas allow recovery. No fishing, no extraction, just protection. Fish populations rebound. Corals recover. Biodiversity increases within years, not decades. Life responds quickly. When pressure is removed, hope exists. Not blind hope, informed hope. based on evidence. When we protect, life flourishes. The ocean wants to thrive. We just have to let it. Indigenous cultures have protected ocean areas for millennia, long before modern conservation. Traditional fishing practices, seasonal closures, size limits, gear restrictions, passed down through generations. Oral traditions, ceremonies, they understood, take too much, and the ocean gives less. Respect the ocean, and it provides. Not exploitation, relationship. Western science is rediscovering this. Indigenous knowledge, holistic, sustainable. The ocean was never ours to conquer. It was always ours to belong to. Perspective matters. The ocean connects all humans, historically, culturally, biologically. Every breath you take contains oxygen from the ocean. Phytoplanktons, gift. The water you drink once flowed through oceans, evaporated, rained, cycled. The fish you eat swam in currents that started half a world away. We're not separate from the ocean. We're part of it. Our bodies are mostly water, salt water, similar composition to the ocean. We carry the ocean within us, in our blood, our cells. We came from the ocean evolutionarily, and we remember chemically. Humans are drawn to water. Psychologically, waterfront property is more valuable. People vacation at beaches. The sound of waves calms us, reduces stress, lowers heart rate. Why? Perhaps evolutionary memory. Our ancestors depended on water for drinking, fishing, trade. Safety near water meant survival. We evolved to find it peaceful, desirable. The ocean calls to us, not with words, with feeling, an ancient recognition of home. The ocean is the womb of Earth. Life began there. For 3 billion years, it was the only place life existed. Land was barren, lifeless. Then, 500 million years ago, life emerged. Onto shores, crawled, adapted, but it carried the ocean with it. In blood, in cells, in memory. We're land creatures, but ocean-born, ocean-sustained. We can't survive without it, not for long. The ocean is not separate from land. They're one system, interconnected, codependent. Harm one, harm both. The ancient oceans are gone. Panthalassic, Tethys, Iapetus. But their legacy remains in mountains, in rocks, in fossils, in the salt in your tears, in the rhythm of your breath. You are made of ancient oceans, literally. The atoms in your body cycled through them, the calcium in your bones, the sodium in your nerves, ocean minerals, ocean chemistry. You're not separate, you're continuous with the ocean, with time, with Earth's deep history. Every ocean that ever existed still exists, in transformed form. Water molecules are ancient, recycled, eternal. The ocean floor is recycled, subducted, melted, reformed. But nothing is lost, just changed, moved, repurposed. The ocean is cyclical, always has been, always will be. As long as Earth has water, as long as the planet lives, the ocean continues. In 5 billion years, the sun will expand, become a red giant. Temperatures will rise, oceans will boil, water will evaporate into space. Earth will become dry, lifeless. But that's 5 billion years away, a span of time we can't truly comprehend. For now, for longer than humans will exist, the ocean is safe, stable, life-giving. We don't need to fear the distant future. We need to care for the present. The ocean's fate is in our hands. For the next few centuries, maybe millennia. After that, evolution takes over. New species, new adaptations. Life continues, with or without us. But while we're here, We have responsibility, not ownership, stewardship. The ocean doesn't belong to us. We belong to the ocean. It made us, sustains us, will outlive us. The least we can do is respect it, reduce plastic use, support sustainable fishing, protect coastal habitats, not out of obligation, out of gratitude. The ocean asks nothing, but it gives everything: air, water, food, climate regulation, beauty. How do we repay that? By caring, simply, sincerely. The ocean doesn't need grand gestures. It needs millions of small acts, each person doing a little, collectively making a difference. The ocean is patient with us, has been for millennia. We've polluted, overfished, destroyed habitats, and still the ocean provides, absorbs our carbon, produces our oxygen, feeds us. But patience has limits. The ocean is showing strain, warming, acidifying, losing biodiversity. These are warnings, not punishments, just consequences. Physics, chemistry, biology. The ocean isn't angry, it's responding to what we've done, and it will continue responding until balance is restored, one way or another, with us. But tonight, you don't need to carry that weight, that responsibility, that worry. Tonight, the ocean is asking something different. It's asking you to rest, to let go of fear, of guilt, of the need to fix everything. You can't solve the ocean's problems alone. No one can, but you can rest, restore yourself. Wake tomorrow with energy, with clarity, with hope. That's enough. That's valuable. The ocean doesn't need martyrs. It needs people who care, who act, but who also rest. Balance, always balance. So breathe, slowly, deeply. Imagine the ocean breathing with you. Tides rising, falling, the rhythm of waves, constant, soothing, ancient. You're connected to that rhythm. Your body knows it. Your cells remember the ocean's pulse. Let it lull you like a lullaby, older than language, older than thought, just rhythm, breath, water, life. The ocean is dark now. In your mind, peaceful, not the darkness of fear, the darkness of depth, of rest, down where no light reaches. But life continues, slow, patient, adapted. That's where you're going, into deep rest, where consciousness fades, where dreams begin, where the body heals, unseen, unthinking, just being, just resting. Feel the weight of your body sinking, not drowning, supported, like floating into water, buoyant, safe. The ocean holds you, metaphorically, but also literally. You're mostly water, ocean water. You're always floating in your own internal ocean, blood flowing, cells bathing, fluids cycling. Your body is a tide ebbing, flowing, resting now. Let your thoughts drift like particles in water, marine snow, falling slowly through layers, from light to twilight to darkness, down, down. Each thought settling onto the floor of your mind, where they'll rest until morning. You don't need them now. They'll be there, waiting. But for now, let them go. Release them into the deep. The ancient ocean's new rest between catastrophes, between upheavals, long periods of quiet, water moving gently, predictably, life thriving, reproducing, existing, without drama, without crisis, just being. That's most of history. The quiet times, unrecorded, unremarkable, but essential. Rest is essential for oceans, for ecosystems, for you. You've journeyed tonight through deep time, ancient seas, vanished worlds. You've seen creatures that no longer exist, oceans that closed, continents that drifted. You've witnessed change, constant, inevitable, but also continuity. Water remains. Life persists. The cycle continues, always, and you're part of it. This brief moment, this single lifetime, you matter in the grand cycle, not because you're special, but because you're part of it. That's enough. That's everything. Thank you for joining me tonight, for diving into deep time, for exploring ancient waters, for trusting the darkness, the ocean's darkness, the sleep's darkness. They're the same, really, places of rest, of renewal, where life began, where life continues, where you return every night. The ocean surrounds you, even now, even here, in the air you breathe, the water you drink, the salt in your blood. You're never separate from it, never alone. The ocean is always with you, within you, connecting you to billions of years, to every organism that ever lived, to the future, whatever it holds. Sleep now. The ocean is sleeping too, in its way. Currents slowing, tides turning. The dark hours between sunset and dawn, when the surface calms, when life in the depths rises, when the world breathes easier, and you can too. Let the ancient oceans carry you into sleep, into dreams. Let their patience become yours, their depth become yours. Let their persistence remind you that life continues, always, through catastrophe, through calm, through everything. Life finds a way, and so will you, tomorrow, and the day after. But tonight, rest. Close your eyes, if you haven't already. Feel the stillness, not emptiness, fullness, the fullness of deep water, heavy, present, peaceful. Let it press gently around you, supporting, protecting, like floating in the womb, the ocean's womb, where all life began, where you return, in rest, in sleep. Good night, dear listener. May your dreams be peaceful. May you drift gently through your own internal ocean. May you wake refreshed, ready to face the day, ready to care for the world. But for now, just rest, just breathe, just be. The ocean asks nothing more. The night asks nothing more. You've done enough. You are enough. Sleep well. The ancient oceans sing you to sleep, with waves, with tides, with the rhythm of time itself, slow, steady, eternal. You're safe, you're held, you're home, in the water, in the darkness, in the peace. Good night, sleep deeply, dream of ancient seas, of creatures long gone, of waters that vanished, of life that persisted. And know that you're part of that story, still being written, still unfolding, one breath at a time, one heartbeat at a time. The ocean is patient, and so is the night. They'll wait for you until morning, until you're ready to wake, to rise, to live again. But for now, rest. Good night.